A win at the 2008 Time Trial World Championships first earned it the nickname World's Fastest Bike. A monumental victory at the 2009 Giro d'Italia backed up that claim. Introducing the Trinity Advanced SL, designed to propel those who race against the clock faster than they've ever ridden before. To prove that the Trinity Advanced SL is, in fact, the world's fastest bike, Giant engineers have worked to create the Aero Report Card, a testing standard which accomplishes one primary goal of comparing and summarizing the key dynamic and static differences between Giant's premium product, the Trinity Advanced SL, and the products of Giant's key competitors. Here are the frames tested for the Aero Report Card. Felt DA, Specialized Transition S-Works, Quota Queen K, Cervelo P4, and finally the Giant Trinity Advanced SL. In testing these frame sets, Giant realized that it wasn't just one variable that would allow a design to win the test. In fact, it would analyze each design for 3 key variables that performance-minded athletes demand in a winning bike. The 3 key variables that make up this test are weight, stiffness, and aerodynamics. First, weight. While seemingly objective, frameset weight can actually be a highly subjective variable. It all depends on what is considered a frameset. Giant defines a frameset as a size medium, painted and decaled production frame with a headset, a properly cut production fork with all the production hardware such as water bottle bolts and integrated brake set, front and rear derailleur hangers, cockpit including stem, base bar, and extensions, a seat post, and finally, a frameset does not include any crankset or bearings in its overall weight. The next variable on the road report card is stiffness. Now, that's a generic term thrown around the bicycle industry, which Giant has broken down into 2 specific elements: steering stiffness and pedaling stiffness. Scores in these 2 areas are averaged together to determine an overall score in the Aero report card. Steering stiffness is the result of the fork, headset, and head tube all flexing under load. With steering stiffness, more is certainly better. Higher levels of stiffness allow the rider to arc tighter with more stability through the corners, and they allow the rider to have better control under hard braking. Giant tests for steering stiffness in 2 ways. A frontal stiffness test expresses how the front end of the bike deflects under heavy braking conditions. A lateral stiffness test determines how the front end of the bike deflects under hard cornering. Here's how Giant tests the frame sets for steering stiffness. To determine frontal stiffness, each frame set is locked at the rear dropouts. A frontal force simulating heavy braking is applied to the fork dropouts of each frame. Giant then measures the deflection at the fork dropouts by the amount of millimeters the dropouts move. To determine lateral stiffness, each locked frame set has a lateral or sideways force applied at the fork dropouts, simulating hard cornering. Again, the flexing of the dropouts is measured in each frame set, this time by the degree of torsional movement at the dropouts. In both the lateral and frontal stiffness tests, Giant is able to conclude that the higher the value the frame achieved in resisting these forces, the stiffer the frame set. This helps determine the overall steering stiffness in all of the tested frames. Pedaling stiffness is the second part of determining the overall stiffness of each frame set. This can be felt under heavy pedaling, such as sprinting, and as a result of more side-to-side motion of the bottom bracket area. With less bottom bracket flex, more power will be transferred through the drivetrain to the rear wheel, propelling the rider forward faster. To determine pedaling stiffness, each frame set is securely locked at the fork dropouts and loosely at the rear. The frame set is inclined to a 10-degree angle to simulate sprinting, and a force is applied to a dummy crank positioned at 45 degrees. The flexing of the dummy crank is measured in millimeters. In this case, the lower the value, the stiffer the frame set, and the better the pedaling efficiency. The third and final variable to grade on the Aero report card is aerodynamics, or how much airflow the bike, in conjunction with the rider, disrupts as it propels forward. In this test, a stock, medium-sized frame set was tested at the San Diego low-speed wind tunnel. Each bike was built using an identical component selection. A complete Shimano Dura-Ace 7900 group was installed on each bike, and a Shimano Pro cockpit was added to minimize the variables between the 5 bicycles. Additionally, each bike was set up with identical positioning, down to the very millimeter of the saddle position, bar height, and even shift lever position. In order to conduct a truly accurate aerodynamic test, an anatomically correct mannequin was installed in exactly the same position on each bicycle. While easier to conduct, frame-only aerodynamic tests are misleading due to the manner in which the airflow fails to interact with a human body. It's easy for a new design to win an aerodynamic comparison in which no human body is present. It's an incredibly difficult engineering challenge to win the body-included test. A 30-mile-an-hour headwind was established, and drag coefficients at yaw angles of 0, 7.5, 10, 12.5, and 15 degrees were measured. An average of these 5 yaw angles was calculated to present the overall average drag coefficient of each bike, and hence a final grade. So now we can the Giant Trinity Advanced SL. This frame is best at achieving the overall balance of the 3 performance characteristics. It gets an A+ for aerodynamics, proving it truly is the world's fastest bike. While not only aerodynamically superior to the competition, it also scores quite well in stiffness with an A-, and in weight with a solid A. What makes the Trinity Advanced SL stand out from the competition? 5 key technical features work together to make the Trinity Advanced SL the fastest bike in the world. Vector SLR. This full composite, lightweight, and highly aerodynamic seat post is engineered specifically for the demands of the aero rider. A fully enclosed internal seat clamp mechanism locks the post into position without any disruption to critical airflow. Speed control. Trinity Advanced SL's proprietary aerodynamic stopping system, a custom-designed reversed position front brake and chainstay-mounted rear brake that allow the rider to effectively reduce speed while remaining virtually invisible to frontal airflow. Power core. The massively oversized bottom bracket chainstay area features a fully integrated 86mm wide bottom bracket design. The next generation fully integrated bottom bracket standard and intelligent chainstay design provide unprecedented pedaling stiffness. Mega Drive. The massive aerodynamic down tube and highly profiled top tube work in unison to provide unprecedented front-end steering precision, all while in strict observance of the UCI's 3-to-1 profile rule. Aerodrive. The real secret to the Trinity Advanced SL's outstanding aerodynamic performance, the stem and fork control center places the rider in the most aerodynamic position of any bike available on the market today. Its patent-pending design is the first on the market to solidly interlock the stem, fork steer tube, and fork crown, creating not only the most aerodynamic design, but also the stiffest steering front end. While other models may score higher in one individual category, riders must consider the compromises of such one-dimensional frame sets. For example, is it worth sacrificing stiffness in order to achieve lighter weight? Or do you want an incredibly aerodynamic bike only to find out it's too flimsy to ride? Or do you want to ride the frame that balances all the variables the best? The Giant Trinity Advanced SL provides all the performance you could ever ask for. As you've seen over the past 10 minutes, the Aero Report Card proves that the Giant Trinity Advanced SL is the overall leader in balancing the 3 critical variables of weight, stiffness, and aerodynamics. The 3 key qualities that riders looking for every possible advantage can count on to propel them to the top of the podium. The Giant Trinity Advanced SL truly is the world's fastest bike.